40 here, 0 here, and 40 here. 80 minutes by each car. So adding this extra resource has made matters uniformly worse. This seems to violate the basic intuition. You see, if I tell you that you have 3 options, alpha, beta, gamma, and if you take this option, you will earn 40. If you take this option, you will earn 60. If you take this option, you will earn 30. Great. And if I give you now, so if you have just these 3 options, you can get 60. Right? And now I give you a 4th option, delta. Whatever it gives you, you can't be worse off. Huh? So how is it that adding an extra opportunity hurts you? This seems to suggest that you can always ignore the extra option and not be worse off. Well, what's the difference between this and that story? Here, it's one decision maker, and the presumption is that when you add delta, these numbers are not changed. Right? That's the hidden assumption when I say an extra option can't hurt you because you can ignore it, because you're pretending that when you give that extra option, the old options are still paying off as before. That's not true in this example. Because what happens to you depends not just on what you do, but what others do. That's the sine qua non, the defining feature of a game. You only partially control your own fortune, it also is controlled by others. The payoff to any person depends not just on what he does, but on what others do. Also, partly on what he does, partly on what others do, which is what is happening in that scale of 2 cities. And which is why this particular illusion, which comes from a one-person problem, is turned on its head when you go to the interactive problem, rational interaction among many people. 4,000 people in that example. So that's one example. And this, by the way, is called Bayes' paradox. And I can tell you a little more mathematically about it without any proof. You could ask, is this paradox a feature of this highly concocted example I gave? Or does it happen more generally? Maybe it happens in very odd examples that we cook up, and most of the time it does not happen. I'm going to answer that at 2 levels. One, as a mathematician, which is what I am at heart, if you take a random graph, then 50% of the time Bayes' paradox will occur. I have not defined random, I haven't defined. So random means you pick nodes with probabilities, you put arcs with different probabilities everywhere, some kind of random model of a graph, and also random cost. And then you ask on what fraction of this set of random graphs will Bayes' paradox occur. And the answer is, as it will occur as many times as it won't occur. About 50% of the time you will be faced with Bayes' paradox. Also, I believe if you Google it, then you will see examples of cities. One is in Amsterdam, one is somewhere else, Singapore, I think, where they built additional roads that everybody was worse on. Traffic got badly affected. So this is one example. It's not a real world example, it's just meant to hook you on a little bit to get into it. I'm now going to give a second example.